Okay, hello to everybody. Welcome to the World Nuclear Exhibition 2025, and thank you for joining us today at our workshop. My name is Ramon Gasull. I'm representing the company TÜV SÜD. I'm working in sales, head of sales, leading the activities that we have in sales for the nuclear industry. For those that don't know very well the company TÜV SÜD, we are a German company. Probably you heard our name because we are providing inspection, testing, and certification services. But probably what you don't know is that we are also active in the nuclear industry for more than 60 years as a technical support organization of the authorities in the south of Germany. In addition to these activities, we are also since many years supporting new build projects and operating power plants, not only in Germany, but abroad. And today, what we are going to present to you in this workshop is a bit our experience in these new international projects, where, for example, since beginning of this year, we are the owner's engineer of raw power in Romania for the new build project of a small modular reactor in Romania, in this country, which is one of the first projects, not only in Europe, but also all around the world. And we could already have some lessons learned and explain you our experience in this project. First of all, this is the agenda that we'll follow today. We'll go through the current nuclear context or landscape. We'll explain you what is our view on the nuclear industry nowadays, and then we'll go through the main challenges that we identified in this kind of new build projects and provide you with some solutions or potential solutions that we think that should be implemented or could be implemented to at the end be successful in this kind of projects. And finally, of course, we'll wrap up with some takeaways, looking to the future and hoping that in the next years many of these projects will be successful and will be converted into running, operating nuclear power plants. So first of all, maybe just to understand where we are as a nuclear industry, everybody that is following the news can see that in almost any country in the world, there are plans for new build projects. This is something that is new in the industry because there are nuclear power plants and new build projects since many years, but there were never so many potential plans of projects at once in the industry in almost all countries, not only in Europe, but all around the world. We have newcomer countries like Poland, we have the, let's say, the traditional countries like France, United States, all of them looking at new build projects as well. We also have Southeast Asian countries, for example, that until now didn't have any nuclear power plant, but are looking now at nuclear new build projects. So this is a new context that we are seeing since few years in the nuclear industry. And of course, it's creating some additional challenges to the industry on top to the ones that we already had in the past. When we look at the factors that are driving these challenges, first of all, as mentioned, we have newcomer countries. What does it mean? So countries that until now didn't have or don't have any running power plant. And these kind of countries, they are facing challenges because they don't have the experience, they don't have regulator, they don't have employees, let's say, or task force that is experienced and qualified for this kind of industry. So this is the first factor that it comes into the picture. Then we have also new end users. So nuclear industry nowadays is not seen anymore as let's say a power plant that it's for generating electricity for the conventional applications, but also there are on top of the data centers, which is obviously in the news every day, it's also being considered now a source of heat for the industry, so process heat, also for district heating, And these are topics that are coming more and more often. There are already some projects in some countries for this kind of applications, but nowadays all the projects, or many of the projects that are being considered, are considering these applications also for their projects and in their business cases. And finally, we have new technologies. So we don't have anymore the typical light water reactors generation 3 that we know in the industry since many years, but we have small modular reactors, some of them based on the large light water reactors that are well known, but also introducing some news or some innovations related to manufacturing process, construction concepts, and so on. And also, of course, there are the advanced modular reactors that come with completely new technologies that have not been constructed, let's say, for commercial power plant until now. And then on top of this, we have fusion energy with the ITER project that it's well known, I think, for everybody, but also individual companies or startups now are launching their own projects in Germany, but also in other countries like UK, etc. And this is also something that it comes on top. So combining all these factors, it's a quite interesting new picture for the nuclear industry, because in addition to all the challenges that we already had as an industry until now, this makes some of these factors add complexity and additional difficulty to the challenges that we had already as an industry. Today, we will go through 4 challenges that we think that are crucial in this industry and also for the success of these new build projects. But of course, there are others that could be relevant or could be also applicable and should not be forgotten. First one, manage multi-jurisdictional requirements. What does it mean? So let's take an example. There is a new build project in Europe with a technology vendor from North America and with supply chain for long lead items in Asia. So just having this combination, already you can imagine that the project in terms of requirements will be complex. There will need to be considered different regulatory systems, regulatory frameworks from different parts of the world, which are not, at least until now, really harmonized. On top of this, it could be that the technology vendor, for example, already certified their design, let's say in North America with the NRC, which has a very specific licensing model and licensing phases, which is completely different to the licensing phases that we have in many countries in Europe. So this is the first challenge that you can imagine. Then, second point, the technology vendor followed specific safety philosophy to justify the safety cases or the safety assessments, which could be, for example, more probabilistic or more deterministic, which is also not exactly the same philosophy that the regulator in Europe, where the project will be built, is following. Then also some regulators are, for example, more prescriptive based. Others are, like in UK, ONR, it's a bit more performance based. So this also could create additional challenges during the licensing process of the project. And then on top of this, we have the codes and standards, let's say at the equipment level, system level, and so on. And on one side, we have, of course, the nuclear codes and standards. But what it should not be forgotten is that the nuclear power plant, it's not only built with nuclear components, but there are also many conventional components that have or need to follow the applicable regulatory framework for industrial, let's say, equipment and systems. So these are a bit the 3 points that come to our mind in this regard. And then the question is, okay, what we can do to address these topics or these challenges, how we can solve it. So first of all, we need to do a regulatory mapping. With this, at the end, it means is to understand what are the gaps between the different models that are applicable to the project where we are involved. And also what usually it helps is to use independent third-party assessments from companies that add trust to the system and also justified some of the decisions that they are made so that the regulators can assess the provided documentation and input in a way that they can understand it also and can be trusted. And maybe then the last point, maintain a common licensing basis, what here is meant. So especially for the technology vendors, probably they have projects in different countries with different licensing frameworks. So it's important that they keep in all projects a common licensing basis and they understand that the steps that they need to take in different countries can be met providing or demonstrating that the safety cases are fulfilled and that they can justify based on deterministic or probabilistic calculations the results of their safety assessments. Second challenge, demonstrate technology maturity. So we mentioned before there are a lot of new technologies that are being developed at this stage, and many of them are first-of-a-kind projects. So there is no reference plan in operation, which is a risk, of course, for the first project that it will be constructed. So there is no operational data. So all the justifications have to be made based on calculations or based on some prototypes or tests that have been carried out. Then, as I mentioned, the SMR projects or the Advanced Modular Reactor projects, they are very promising in terms of innovation. So they are proposing construction processes and manufacturing processes that on one side they should be faster and enable these projects to be constructed faster, but of course are not processes that have been implemented until now for this kind of facilities, and therefore they need to be demonstrated that they are working. On the third topic, it's the increased utilization of commercial off-the-shelf components. So many of the projects or the plants that exist nowadays are considering the use of more commercial off-the-shelf components, so COTS, instead of the typical nuclear qualified equipment. And this is something that is adding also complexity in order to justify if these components are suitable for the applications in the nuclear power plants or the nuclear facilities, considering all the requirements that we have. How to address these challenges? So maybe the first thing is that technical readiness, it doesn't mean that it's already for the regulator ready. So some of the technology vendors have a concept, has the technology, they are convinced that this will work, but it's not so easy to demonstrate it. So because there, as I said, there is no operational data, so it's needed to provide some proof to the regulators that they can understand it and they can justify it. Second topic, regulators need validated data, is a bit the same. Regulators love to see data of not first-of-a-kind facilities, but reference plans. And in many projects, it could happen that the second of the kind, it's built or it's constructed in parallel to the reference plan, which makes this topic quite complex because there is no available data. And then the third topic is independent verification to accelerate the acceptance. So especially some of the regulators are not so convinced if all the input is provided by the licensee or by the technology vendor through the licensee. So they like to see independent models by independent third parties, independent results, maybe with different softwares if there are calculations to be done, so that they can have a second opinion and understand if the results are acceptable or some additional concerns may be raised regarding the safety or the operation of the facility. Next topic is operational readiness. That's more related to the licenses or to the future licenses. What this topic is very relevant nowadays. So in the past, in the nuclear industry, most of the operators of nuclear power plants or licenses, let's say they were well-known established companies. You can think of EDF in France, for example, ČEZ in Czech Republic, etc. Nowadays, because of also other end users are entering into the industry, They are grounding new companies that will become future operators of nuclear power plants, and many of them don't have any experience until now in this industry. Usually how it starts, it could be similar in other industries. It starts with a nuclear program, so there is an idea for a project. Then there is a startup company that is grounded to initiate, let's say, from a formal point of view, the first steps. Then it becomes project development company, and at a certain point it becomes a licensee, so when it needed to start the licensing process of the nuclear power plant itself. This is not so simple because, as mentioned, the company need to grow and understand what they are doing and justify it in front of the regulator. And it's why the workforce that is needed for this kind of projects and the competency of the workforce that these companies will have during the life cycle of the projects need to evolve as the project also evolves during the life cycle of the project. This is not only about the personnel, it's also about the processes of the company, so the management system of the company. So the company will start having some plans, maybe feasibility studies to be carried out. Then there will be design and construction part, and at the end it will become, after commissioning, an operator. So you can imagine that the processes that you will have in the management system as a legal entity or as a company also will need to evolve, because the focus will not be the same during the entire project life cycle. And then maybe a third topic that it's always maybe a bit forgotten, it's the interface with the regulator. So there will be interfaces with the regulator from the very beginning of the project, but this will also evolve through the lifetime or the life cycle of the project, and this also needs to be considered. Also, depending on the country where the regulator is based, also depending on the experience of the regulator or on the technology that the regulator already evaluated until the point where this project starts. It's important to make some thoughts on how to approach the regulator, what kind of package of documents the regulator is expecting in the different phases in the project, so that they are convinced about the input that is provided and they can accept the results. What we think that it's always helpful is, on one side, to have progressive readiness reviews during the different life cycle of the project. This is important to have it integrated in the daily operations, and not only as a milestone in the time schedule, but also having direct impact on the decisions that are made related to the execution of the project. Then another topic that usually it helps is to develop a nuclear baseline. What is a nuclear baseline? It's mainly to identify in the different phases of the project what kind of personnel do you need as a company for this project, and what are the skills that this personnel need to have, and how much people in the different areas you need. Because it doesn't make much sense to hire a lot of people with maybe construction expertise if you are still, I don't know, in the very initial phases of the project doing the feasibility study. Or later you will need more people at the end with the expertise related to commissioning activities, for example. And this needs to be well planned, because it needs to be then integrated also in the human resources plans of these kind of projects, and it's not so straightforward. Also because nowadays there is lack of human resources or qualified human resources in the industry, and this is a topic that it comes on top. Then the third topic, it's become an intelligent customer. So what it means, become an intelligent customer. So the regulators like to see that the future operators or the licensee of the nuclear facilities take accountability of the project. So it's not only looking like you understand what you are doing, but really proving that you understand what you are doing, that you are making informed decisions, and that you are not only relying maybe on what the technology vendor is providing to you. And this is at the end what it means become an intelligent customer. So making informed decisions, take accountability, take into consideration nuclear safety in your organization, prove that it has been transferred to all the different levels of the organization, and that you work as an entity that is able to manage a nuclear project. last topic, manage global supply chains. As I mentioned at the beginning, so we see that nowadays, even in some countries, we're coming back a bit from the global to the local, but still in the nuclear industry, the number of potential manufacturers, equipment suppliers for some of the fields is limited, so international supply chains are still in place, and also in terms of capacity, probably it will be needed also in the next years. So the first challenge that has appeared, it's the different codes and standards for the equipment, but it's not only the codes and standards, in some cases it's also the safety culture or the culture in the different countries. So there may be misunderstanding on how the codes and standards are understood at the operational level, not because they are written in one way or in another one, but because the interpretation of these codes and standards differ, or it depends on who is reading this, and based on their background, they can understand it in one way or another one. So the second topic, it's counterfeit and fraudulent and suspect items. That's a topic that since many years now is in the industry quite popular, let's say. And if you have global supply chains, this would be also an additional challenge that comes into the picture, because you will need quality assurance programs that ensure that globally the level, let's say, of assurance of the quality is at the same level. And the third topic, it's long-term supply chain availability and resilience. This means that it's not only a power plant for the time of construction. So it needs to be run maybe 60 years. You need availability of components, if possible, during the 60 years, because modifications in power plants are usually effort intensive, especially if they're nuclear qualified equipment. And if you don't have a spare parts for this kind of equipment, it may cause some additional costs, some additional travels during the future phases of the project. How to solve this kind of, or overcome this kind of challenges? First of all, 360-degree supply chain oversight, so a comprehensive supply chain oversight, having regular audits at your suppliers, having quality assurance programs that are globally at the same level, defining requirements for the equipment independently if the equipment is coming from Europe, from the US, from Asia, whatever, and so on. So that's the first point. Then apply internationally recognized standards. For example, there is the ISO 19443 nowadays, which is a certification for the management system of companies in the nuclear supply chain. And this is a good example of an international standard that could be used, or it's already being used, but it will be rolled out more and more in the industry, and then we'll have a similar level all around the world, independently from the country in which the supplier is based. And then build long-term partnerships. So this is a bit what I mentioned. So it's important not to think only on the construction, but also think that the plant will be in operation for probably more than 60 years. So price will be important when you will buy the components during the construction, but if later this supply is not reliable and cannot supply you the products after maybe 10, 20 years, whatever, the cost that you will have later may be considerably higher than what you initially expected during the construction phase. Then one thing that we also looked at TÜV SÜD, it's, okay, usually the license is on the spot, but it's not only a problem of the licensee usually, so it's kind of shared responsibility by the different stakeholders that are involved in a project. So here we have developed an example of how a new build project could look, what are the main stakeholders. And for example, if we take the example of technology maturity, of course it's a problem or it's a challenge for the EPC company, because they need to prove that what they are selling is mature and it's working. It will be also a challenge for the licensee, because they will need to justify it to their investors as well to the regulator, and also for the investors, because if it's a first of a kind problem, for example, they will consider that there are additional risks that they need to be considered, so they will also want more guarantees. And for the authority, of course, if it's the first time they see this kind of technology, they also will need to understand if it works, it doesn't work, and if the justifications provided are sufficient. So as you see, if you take just one of these examples, it's at the end shared challenge between different stakeholders, and this is not easy to overcome, but there are roles in the industry that can support this kind of collaboration between the stakeholders. These are different examples. For example, for the investors, there are lenders, technical advisors, or for the authority, technical support organization. At the end, the most important thing is these companies that work independently, that they provide their independent assessments, they support their customers to move forward, to enable collaboration, and to provide trust in the whole process. Last slide, key takeaways. So some of the things are a bit already mentioned, but the first one, it's like regulatory compliance. It's not administrative, but it's a strategic thing. It needs to be really implemented and integrated through or in every project decision. And if possible, during the operations, have it integrated in the technical departments that are working in nuclear new build project, and then make the right decisions so that the licensing process is carried out as more fluent as possible, let's call it this. Then early integration of the requirements to avoid reworking. Reworking is one of the main problems from our point of view that is in the industry, and it causes a lot of delays, and it's one of the main risks then for this kind of project. So it's really important that from the very beginning of the project, the framework, the regulatory framework is really understood, and then measures can be implemented to minimize this risk. Technology maturity, I already mentioned, it really needs to be demonstrated. Just thinking that we'll be able to demonstrate that a new technology is working and can be constructed with only based on simulations, our experience is that this is usually not working and something else is needed. So some tests, some prototypes, etc. And this is usually a crucial point, especially because nowadays there are many new technologies that are being developed and for which there is no reference plan in operation. And last but not least is how to earn confidence. So at the end, there are different pillars that need to be robust. So safety needs to be robust, quality needs to be robust, accountability needs to be robust, and also, of course, the culture of the licensee, especially in this case, needs to be robust so that the trust is provided to the other shareholders, and this enables the success of such a project. So this was everything from my side. If you have any questions, I think I will be in the room next to the stage. Also, you have my contact details here. You can contact me anytime. And it was a pleasure. And I hope to see you soon. And of course, visit us at our booth, M49. So if you have any question, we'll be happy to help you and to support your projects. Thank you very much.